Good evening, everyone. How's everyone doing? Sorry for the incredibly late start. I have had problems. Hi. This wasn't the part of Luna I wanted. That was the part I wanted. Just setting Glasgow related things up. So I have a debug adapter. I have news on the front of debugging. Very exciting news that is very hot off the press. This is just going to take me a moment to sort the giant mess of cables out, and yeah. I have too many USB things on my desk right now. Well. Just for this project alone, I am going to be using 6 USB cables. Because I've got the protocol analyzer up and running. That will become clear why later. So the plan for today's stream is to try and get a keyboard talking USB HID. And there we go. I'll just have that cable loose for later in case I need to Glasgow. Oh yeah, 6. Yeah. So, before I get into the meat of things, the news. Luna is still a thing. If you want to try and get your hands on one nice and early, do subscribe to Crowd Supply. I'm not currently using a Luna for reasons, but I'm hoping to have mine arrive shortly. It is in the mail to me to arrive imminently. They're very, very good devices for doing, among other things, traffic analysis like we're going to be doing tonight. I, however, am currently using a OpenVisla, which is good, but could do with some improvement. Let's put it that way. I'll be polite to how bad some of it can be. The other bit of fun news is that I have now started Tempest. Tempest is my reverse engineering work for the JTAG PDI protocol that the processor that is on MX Keyboard uses. This is a fully black box reverse engineering of the protocol and all the registers that are required that you have to be able to read and write, etc. with the intention that I'm going to create a resource in this process for anyone who wants to fully open source, clean room implement the protocol to have the information they need to be able to do so correctly. This is something that I have yet to find done anywhere else, and I kind of got fed up of the proprietary tools. As you could probably tell from previous MX Keyboard streams, they are not good tools. As you can probably also already tell from what I'm showing here, where I'm showing Register 3, I've already cracked some very interesting, otherwise completely undocumented things that are... Yeah, this is fun. So, if you want to follow along with this project, it's github.com/dxmonthly/tempest. And this is the GitHub Pages website, which is a... I'll put it in chat for you. If you want to have a read, then go there, and you can learn all about the PDI protocol and its fun on Xmega at very least. At some point I will try and get the information needed for the other variants of the protocol, because there's more than one. And they're all different in ways that need documenting that make it more difficult to write a debugger for the whole series of chips, etc. But at least this gets us started for 80X Mega, and as of yesterday, I actually did a full manual debug session on the other MX keyboard board, because I didn't want to accidentally brick this one. And I was able to manually do full run to breakpoint debugging and dump all the registers out, etc. It was great. It's surprisingly easy to do as well, at least with the applet I've written for Glasgow and so on. You'll see more about that later. Hey Lofty, welcome Sylvia, welcome Obliterous. But yeah, so Tempest is this nice project I've got going for documenting JTAG PDI, which may come in handy later tonight, so I'll leave this open. That's why I've got a Glasgow in my signal chain right now. So, without further ado, USB HID. I'm honestly nervous about this because I don't quite know where to start. So we've got the keyboard where we can like press keys down and we can see the LEDs change color as a result. That's this code here. Hey Araki, welcome, welcome. This is where we're handling key presses and releases. We need to... you're welcome. As you've just joined and you missed it, I was just talking about JTAG, reverse engineering, my JTAG PTI stuff. I did not yet write all the descriptors, we're going to have to do that in a moment. I was going to first look at doing key to scan code translation and get those tables working first. So, yeah, JTAG PTI RE is a thing. There's a link in chat if you need me to repost it, I can do so. This is a full documentation of the protocol that is used between JTAG adapter and keyboard to do debugging and programming. But the important one is debug, because that's not documented anywhere else that I know of. So... I'm gonna start by grabbing another keyboard I have, and I'm going to read out what its descriptors say, because the HID spec wasn't particularly clear on exactly what needed writing to make a USB descriptor. So this is the other keyboard. It's a gnarly one, but whatever. It's good enough for what I want right now, which is if I plug it in... Surprise, out of the way. There. And we open a console. We can do ls USB. Maybe. Why is that taking forever? Let me check on my kernel. Let's take Glasgow out of the loop there. Okay, that makes very little sense then as to why this is taking forever. Yes, I plan to do that. I'm having issues right now with my USB stack. This doesn't make any sense. So, this is fun. I'm gonna have to reset USB on this machine, I think. Oh, it finally got there. But I wonder what device that was that's causing this problem. It's unhappy with 5-1, which is my Vizsla. Why is it unhappy with Vizsla? Let me unplug Vizsla completely and plug it back in. Anyway, we want to no, not my Pixel. This one, the Microsoft keyboard. This is what I want to do a listing of. So we want to do verbose device that. That made the XHCI HCD driver angry. Interesting. This isn't a good sign. Putting Glasgow back on the chain isn't gonna hurt anything because it's not plugged in beyond being attached to the JTAG chain. It's got no power, so it's not doing anything. Oh, I wonder if this is because I haven't yet given Vizsla a bitstream this session. Vizsla is now configured. Yeah, we're still stuck. This is interesting. Well, I'm gonna get the hits back open at the very least so we can start poking things. I was hoping to look at like scan codes and what's happening there. But, I'm not allowed apparently. Page 21. Of course, nothing of this is hyperlinked, which is great. Page 13. No, I asked for 21. Jeez. Really? Oh no. Also, hilariously enough, my USB hub is so angry that it's just made the scheduler cause a small call trace. Wow. I'll give that some time, it'll probably fix itself. It usually does. Not great, but... what can you do? Although, oh, actually I know what I can do. I can go and put back on my machine. One moment. Treat it like Windows? Why? Why would I do that to a good machine? Scan codes in another document. That's frustrating. Well, okay. Sure. You're kinda not wrong, unfortunately. Head. Yeah, is there a, trawler for the USB IF website already? Usage tables, the HUT document. I actually have that down already. That's this one. Well, I didn't think this defined the scan codes. It might do. Oh my goodness, giddy aunt me. Unicode page. Box display. In theory, I will be able to make this work so that you can control the LEDs over USB. Yeah, this doesn't appear to have scan codes. Unless that's actually what's in each of these pages. Oh. Yes. Okay. Wow, this is gonna be fun. Okay. What's the link, by the way, to Esden's thing? I guess it's github.com/esden/something. Thank you. Did he push it yet? Firmware. Yes. Yes, he did. Hmm. Oh, thank you. Ah, there we go. Thank you. Amazing. That's fine. If it gets me where I need to be. Because I remember I got partway through describing descriptors, but I kind of paused because I wasn't sure how to go about describing some of this stuff. So we've got here with a special operator or usage global so this should generate me, what is this, a 5? Yeah, 5. This should become 1. Yep, 1. Generic desktop. Again, usage, this time local. So that's 9. Yep, 9. Apparently I set keyboard as 9, you set it as 6. Interesting. That'll have been because of this document. Button page is what I've defined that as, apparently. Is this some silly thing where the HID spec says something different to that spec? So you did. So I remember I did poke around this spec before in a big way, and one of these has a table which says that you should use 9 for keyboard, but then I think there's another one that says you should use 6 for keyboard. And I never found the right part of the appendices. It was this thing. There we go. So we've got the country codes, we've got short items, long items, main items. So this defines the encoding for these first bytes in each of these two cases. And then there's global items. Which is where we get usage local from. For a list of usage parts, see Appendix A, usage tags. Standard requests. Get and set descriptor. That's the one I need to implement to be able to send back those. Well, this is unhelpful of their own spec. I think I might have gone and dived into here and started at this, and I went and found the local usage pages. I think that might have been how I did this. Yeah, because this is generic device controls page, and I saw button page, and I think I went button page as a result. Oh boy. Well, let's fix the bad code. System usage. Because we said it was generic desktop page, so it's usage page generic desktop. That then determines how you interpret the next thing, technically. Oh yeah, and 6 is keyboard. Haha, 9 is the tablet stuff. Okay, I just simply got it wrong. Cool. So we then need to define a head descriptor T collection. It's going to be a thing. This is then going to be followed by head collection type application, and that looks like that's where they hit the descriptor size of 1 again. Ah. Oh, this is just hit description T that. And then this follows after. So collection is A. That's There's a short item. Hey, oh, welcome, Esden. That's still not come back. I'm just gonna unplug the other keyboard and we'll deal with it a different way so I don't have a cable trailing across me. Well. I know I do. Nope. Try that one. Yeah, that's going to be a fun part. I'm currently looking at how I want to piecewise define things. I don't know. Rather than defining magic constants that just do stuff and writing what they translate to by the side of them, I'm trying to do this in a slightly more descriptive way where, like, you can see, oh, okay, so it's a collection, type main, etc, and build it up that way so I don't have magic stuff all over the place. And that's proving to make my life a little bit more complicated right now because I'm not actually sure how to describe this bit. I think I'm gonna add it here and fix it later if it's wrong. So if we do collection is A0. I've already got this operator OR that combines stuff for me correctly. NN is the size, so this logic's all fine. So we then have collection type T. Yeah. There's a lot of kowtowing to broken things rather than just fix it. Which is what it is. Oh, perhaps if I put that as an equal sign. Application 1, logical 2, port 3. And array 4. Switch 5. usage modifier. And the other ones are unused. Kind of. It does, yeah. Yeah, I think this is the data byte following collection has to be this, which would make sense. Which we've now got. So we then go into a usage page, a global usage page at that. That is key codes. Now, it would be handy if I could actually find a listing of all the usage pages. Because this is page 1. Yeah, this is usage page keyboard. Which is page 7. This one. I would have to agree with Esden there. Also, I wouldn't not specify the descriptors just because assumption's bad. In addition, I'm going to be doing an extended mode for this thing, so at some point I will go and add a whole pile of extra stuff. And usage minimum, usage maximum. What on earth are those, and how do I specify those nicely? So to explain where I'm at, I'm currently here at these fun things, which define a usage minimum and a usage maximum, and we're not sure what those do yet. Let's go find out. Although, before I continue writing descriptors, yeah, okay, so what I was going to do originally was I was going to write a table of key codes to, well, keys to scan codes. So let's do USB scan codes real quick. This looks like everything fits in 1 byte. At least for boot mode. So we've got LED index. We need to add UNT USB scan code, which we can initialize to 0. Yeah, let's go with 0 for reserved. And we'll add that as well to KeyT, which is the Flash version of everything. Yes, however, Sylvia, you can't say that you are boot mode at that point. You actually have to be able to support switch mode and provide a descriptor that describes how you've packed a larger number of keys. This is actually what I'm planning to do here. That's one of the reasons I should actually implement the HID descriptor stuff properly, because I'm going to need to be able to extend it out later. Yeah, that's what set protocol's for. It's actually you fall forward, not backward. You start in boot mode, the host goes, oh, you can do not boot mode, and I support that. Set protocol not boot mode. Now you're talking not boot mode, and it gets extra descriptors out of you and does stuff. I know that that's how that works. We'll come back to that. So, first key to map is escape, which is usage ID hex 29. I thought you had to start in boot mode because otherwise UEFI and BIOS that are broken don't work correctly. It was described to me as you start in boot mode and then you get turned into non-boot mode by reporting that you support non-boot mode, and then you get switched. Well, we'll come back to that anyway. Yeah. We'll come back around to that. Right now I need to try and map. We've gone and put this key here in the map, and I'm going to work my way down. As I fill the map out, this will become a bit more obvious. So this is escape. This is the USB boot code for escape, pulled from the table. Interestingly enough, it actually also gives me the 8100 spec code, which this is backtick by default. So we have to find, where is backtick? Plus minus exclamation mark. That what? There's a scan code for double ampersand and a scan code for double pipe. What? And also one for XOR. Well, we're gonna have to experiment with sending some of these and seeing what actually comes out the other end. There's also ones for, like, setting them... Wow. Okay. There's some interesting scan codes in here. Erase language stuff. Those have notes attached to them. I don't want to just copy stuff without understanding what I'm doing. Actually reading out this table and understanding what I'm seeing does make a lot of sense. What I might actually do, rather than doing this way, what I might actually do is I might write a table of the scan codes as an enum, and we'll use the enum here instead of the uint8t. So if we do enum class USB, yeah, exactly, right? Copying it wouldn't get me that. USB scan code T. Yes, I know it does, but I've been, see, I know, I've done that there, damn it. I was trying to be consistent in this codebase and only use one or the other. I'll have to fix the other code. I'll switch the other code to use enum struct. So, Sylvia, there are two little problems with that. One is, if you decide to make your big mode, your non-boot mode descriptors not match the boot mode ones to start with, let's say because you want the reserved byte back for various reasons, then you'll have an incompatible report. And the other one is, what if someone left a book on top of the keyboard and the computer reboots? I know it's a bit of a what-ifism, but it's something I do actually need to think about here. I'm gonna make these so I have like A, B, C, D on a line, and then we'll go to a new line. Okay, I was gonna do it numerically, but actually this makes more sense for me to match the spec on this. I have missed a letter in the alphabet. A, B, C, D, E, F, G, H. I, J, K, L, M, N, O, P, T. I forgot W. Okay. So yeah, I is C, J is D, E for K, F, L. Code simplicity doesn't really matter at this point because I'm going to be letting you. I'm going to have to make you implement your own scan code table for USB and your own scan code table for PS2. So the code's not that simple in that way anyway. Yeah. I give you that it is enough for most. I do want to robustly implement BIOS UEFI support here though. I I wouldn't put it past vendors to be doing dumb stuff still. No offense to vendors in the chat, but they have a habit of being silly. Although, as Lofty Core people would say, you're all vendors, just to different degrees. Even me. Yes, exactly, Esden. Oh. Yes, I typed use scan code wrong. B W X Y and Z. And we get to do 0 to 9. Well, actually, it's specified in the wrong order. Interesting. Now, here's a question. Identifiers. I'd like to represent the numbers as numbers, but obviously I can't have a variable named 1, the number, rather than the word. _1? Noting I'm in my own namespace, so I'm allowed to have underscores. I think I'm going to do that. It makes it a valid identifier and allows me to use the numeric, so you don't have to spell the number out everywhere. At 23, good. That would be error rollover, right? This top one. Huh. I better actually add those then. Hey Jade, welcome, welcome. That was supposed to be 2A, not 2B. 2C for that one. Let's dash. Equals is 2e. Left. Brace, is that? Square brackets? No, that's brace. What's the proper formal name for that character? Let's go and actually find out the character's name. Google, you sometimes frustrate me. Apparently it's just bracket. Yes. Yes it does. This is part of why I was commenting about how I was intrigued that you like chiptune music. Because, same. Just make this completely consistent. Good choices. Semicolon is 3 Oh, there's graph accent and tilde. That's... interesting. That's not used on a British keyboard. So it says single quote is hex 3 4 U graph accent 3 5 U comma is 3 6 U full stop is 3 7 U / caps lock. Oh my goodness. I can't type tonight. Yay, this is gonna make it so much more interesting. F5, F6, F7, F8, F9, 10, 11, F12. It is objectionably hot over there, isn't it? What is the weather coming to when... yeah. Oof. Oh. What is that in real money, please, Obliterus? I don't talk American, so... Print screen, hex 46. Oh, nice. What on earth is delete forward? Ah. Well, you and Aki can do a switcheroo then. I think it might be a special character which instead of backspace, which is delete backward, allows you to delete the thing immediately after the cursor. So kind of like how the delete key works, but not the delete key. Kind of, yeah. Oh no, I've got the hiccups. Well, we'll find out in a moment. Yeah, this is much nicer having these accurately describe. Insert is hex 49. I keep getting lost in the table. It's a lot of white and not easily navigated. Unlock and clear, interesting. Let's divide. 54. Multiply 5. Now, oh, that's a good question. Should the dot character be called full stop, which is technically its proper name? It does. Or should I call it dot? I'm gonna say full stop, but it's technically on the numpad, it's technically decimal place or decimal point. Huh. Period. Oh, period's a good word. I like that. Sylvia, is there a tool that runs on Linux? I don't really want to have to deal with wine if I can help it. Of course there isn't. Thanks for trying. There's a difference between US and non-US backslash? What? This is US backslash. We then have international backslash, which is what they really mean by non-US. Power key, wonderful. Keypad equals. Ah, I did not know that you could actually get a keypad equals sign. I've never seen a keyboard with one of those on. It kind of makes sense though. And then we have more F keys. It'll be easiest just to copy past to that, and I can then do 13, 14, 15, etc. How's everyone doing, by the way, except for melting? Which I am terribly sorry that Aki is melting, because it's not pleasant. That works. Tea and lunch are good. Eternal mood, at least on the time. Well, no, on both, to be honest. $21. 70. We're nearly halfway there, yay! Hey Keith D, welcome. That works. I am unable to type correctly. It's great. So we've got execute. I didn't know that that was a key either. Today I learned a whole pile of things that aren't exposed on a normal keyboard. Menu is something we do support, so that's nice. Didn't know there was a stop key. Copy, paste. Find. Mute. So this is a media keys thing. That's also the halfway mark. Yeah, that's a mood. There are locking versions of... Okay. Oh, I guess this is if you want to physically differentiate that you've got a locking version of the key versus the latching, sorry, the momentary version typically found on a keyboard. For whatever reason, you might ever differentiate those. Didn't we already have keypad equals? Yeah, we did. We had keypad equals. And now there's another one for equal sign? Okay. I'm gonna skip a few for a moment. Track, cancel, clear, that's a reserved keyword, normally. I don't know what CRCell does, but okay. I'm guessing this is special keys they added for, like, point of sale stuff to add 00 and 000 quickly and easily. There's a lot of stuff the keypad can have that a normal keyboard does not have. Interesting. Apparently, yeah. And they made it into the boot standard of all things. Well, actually, no, these aren't in the boot standard, but they are in the usage page. Yeah, go figure. That's left paren E6. Right paren. And then we have braces. Technically that is parenthesis, of course. There's a keypad tab key that you can have. What? Yeah, I'm just surprised that they are in this key page rather than in their own special ones. Like, the next key codes here, these are clearly for hexadecimal entry keypads. Actually, I'll do that as 3 rows like that. C, D, E, F, C0, C1, XOR, keypad, circumflex is C3, keypad percent C4, I'm pretty sure that those are not actually called less than or greater than, but that's what we tend to use them for. Is it left angle bracket, right angle bracket? I'm gonna go with that for now. If anyone wants to correct me on incorrect nomenclature, please do. These two here, which are in horrible font, what we'd associate with less than and greater than, but which I think are actually called left and right angle bracket. This is C7U, C8U, C9U, C8U, colon, hash, there's another space key. Okay. Waka, 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 waka. Left waka waka, right waka waka. I like it, that's cute. I don't think I can put that in the firmware though. Oh, hi Pyro Peter, thank you. Oh. Fine, I'll call them less than and greater than then. Just because that is unambiguous, at least, versus those two, which are, not the character I thought that I was typing about. Fun. Yes it does, which is quite nice actually. But I don't know that I can directly put those out? Question mark? I'm gonna have to just keep going my way through these because the things I need to define are down here. Keypad exclamation, keypad memory store, D0 U, recall, clear, add, subtract, multiply, divide, keypad plus minus. So this is D1, 2, 3, 4, 5, 6, and 7. So this is entry modes, clearly, so you can switch it into like a binary entry mode, an octal entry mode, etc. Again, these are not normally exposed. This is kind of fun, actually. Oh, I don't need the keypad part on this now. This is just left shift, left control, left shift, left alt, left 3. I wonder if that's meta. Yeah, this is meta, not GUI. So then have right control, right shift, right alt, and we are finally done with right meta. Table down here should now work. Although I still haven't found the accent key I'm looking for, which is that, essentially. Backtick is apparently not defined in this table, which is weird, because it should be, right? Because it's a standard key code. Oh, are they defining that as grav? So, I think we've now done all of these ones here. I think F1 here is 6. So we've got USB scan code F1. I have to skip the song. Let's have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Yeah, because then we get a 255, which is... There's a fixer-upper column over here before we then get into the next bit over, so that's correct. Not 15, 5 rather. 6. So we then have the next lot down, 1 over here. Which means this code's now actually slightly more self-documenting. This is quite nice that just by getting to write this lot in, we are effectively documenting this code. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. There's Q. U. E. R. T. Y. Because yes, I do type on a QWERTY keyboard. I know, I should probably learn something better for my wrists, but I haven't yet. And I think that means this here is enter. Because it's on the fix-up row. Oh, hang on. Nope, I've managed to do this wrong. Ha! That serves me right for not completing the row I was on. So, after 0 comes a hyphen. I mean, mechanical keyboard helps a lot. Especially when it's something like these browns, which don't bottom out when you activate them, so they don't send shocks up the wrists and... I called that dash. Okay. That's my own fault. Has to be scan code T equals. So actually, this isn't enter, this is backspace. Because we're here on this row with no F key above because the F key is finished in here, in this line. We then have... So we've done QWERTY, brackets, meaning that this spot here in this upper row is empty, meaning this is enter. That's this one. Which is the fix-up row. So we then have A, which I'll copy that again, but this time grab just that part. D, F, G, H, I, J, K, L, oh, yeah, semicolon, have I managed to miss a key out or something silly? Got tab, caps lock, A, S, D, F, G, H, O, J, K, L, no I in there, semicolon, single quote, international, no, not international backslash, this is hash, because the other one's on the 2 key if it's American, and so that's, we're here, and then we have enter in that row, so then we go on to this next row here. This is, single quote and at sign, versus double quote, which is over here, with backtick on this key. Because it's a pair, single and double quote, so... fair enough. So we've got our fun backslash, which is actually international backslash. Because this is an international layout keyboard. Z, X, C, V, B. Oh yeah, semantics at the end of the day. N, M, comma, that's a hell of a switch to make. Z versus Y? That's a huge distance. I know that I think it's in France, it's Q and A or one of these pair swap. Which is also quite fun. Azerty, yeah. Oh right, yeah, W and Z also swap, so it's A and Q probably. I'm not gonna get into the politics of that one. It's what they chose. Well, so swapping Y out from here, if your language never uses it, means you free up a common use area by putting it over somewhere where you... Although, oh, you're saying, yeah, okay, that's interesting. Because German doesn't really use Z either, then it doesn't make any sense putting it into a common use area point. Oh, yeah, that's a very curious choice, isn't it? Well, / Oh, that's fair. I'm doing this so that I know the layout versus... And then I can debug things, but then I can switch this over into, for example, Dvorak, and that's... Just rewrite this table once and I'm done. So we got right shift... And nothing in the fix-up row. Sorry, column. Bottom row, we have left control, left meta, left alt. Yeah, having an easy mapping mechanism is, well, you can see the importance of it here, because this is actually pretty nice, I think. This is quite easy to write the mappings for. Right, alt, right meta, menu, oh, I see, I'll look at doing that. That's probably going to be something where I write a utility that takes the common configurator stuff and pulls it into a... because you can talk to this to reconfigure it anyway. So it might be part of that utility is that it does the conversion in on the PC side there and versus the scripting or what have you. Okay, so we're now into this section here... Let me just move the camera a bit. Oops. Sorry, that's very bright down there. So we're now down into this section here. So this is print screen. Scroll lock. You are not alone in your hate of QMK's codebase. You and Jade would get along like a house on fire right now. There's pause. Insert. Home. Page, up, not down. Oh, right. I'm gonna have to put an underscore on that one. I wonder if that's that delete forward thing. Because I don't know what else this could be. God, my IDE does not like trying to do that. End is under home. Page down. We then have two spaces and the left arrow key. I'm gonna have to do something special with that one. Up arrow, down arrow. Yeah, this is those two. Right arrow. So then we get into this area, which has no keys in this top row, so that everything's down from there. We then have numlock. Keypad divide. Keypad multiply. Keypad subtract. Keypad 7, 8, and 9. Four. 5 and 6, and I've just noticed I've done these on the wrong... I was supposed to put them up here. Because we gotta deal with the column over here still. Like, that was an unused key that I had mapped to 9. Unused matrix entry. Which is actually the plus sign here is the one below. So this is keypad plus add? Keypad add, there we go. Keypad 1. Keypad 2. Oh, I've just done that again. That's actually keypad 3, 2. This is a table in Flash. Moreover, this is a table in Flash that holds the defaults. I need the defaults somewhere, and then what I plan to do is I then plan to copy this into EEPROM, and then you can rejig the EEPROM rather than Flash all the time. Because I can protect EEPROM from being erased during a programming cycle. So we've got 0, then there'll be a space here where I didn't put a key in the matrix because it's a double width key. Indeed, that's what we see. Then we've got keypad dot, was it we called it, or what did we call that? Obliterous, you gave me a good name and then I've forgotten it. Yeah. Period. Thank you. I've just spotted why return isn't working. It's because it's this one here, _return. There we go. And that resolves... Oh, no, that doesn't resolve delete. That's going to be another fun one. And the last one is keypad enter. That's the mapping. I need to fix delete not being defined, which, let me just grab that, and we'll... It was for CU. I think that's going to be delete. So what I should be able to do is yeah, I'm going to start by putting these out the UART. That means I need to include the UART header. We'll also need to key state USB scan code is key.usb scan code to pull it in from Flash. And then user defined literal is not currently defined because I need to do a using namespace mx keyboard. No, that should be defined. Yeah, it should be defined. Run console. And the build failed. Redeclaration of clear. Oops. Oh, yeah, okay. So there's a clear def here, and there's another one there. Why? Oh. That'll do it. Oh, and it's also complaining because there are some missing initializers. Oh my goodness gracious. That note there is just made of cancer right there. Oof. Well, that's fun. I'm just trying to figure out at the moment what I fill the unused positions here with, and I've also just noticed I made a mistake. Let's just move those two up, and that there is actually one of the ones that's the reserved code. But I don't want to use reserved because I need to somehow differentiate between this reserved, which is for FN here, versus reserved because the key doesn't exist. Although, actually no, because the key doesn't exist, the only way that that can happen is therefore because you did something weird or you're running this on not my hardware. Which, whatever at that point. Welcome back. Yeah, something like that. Oh, fun. Oh, don't worry, you're not the only one. I might have thrown half part of my supper on the floor earlier. Oh, over me first as well, I might add. Yeah, that was fun. I wasn't doing very well earlier. Just putting it mildly. So those USB problems from earlier persist, and I still can't talk to the keyboard. Well, I'll have to go and poke my entire machine to fix this. Unplug and replug every USB device. That's gonna be a pain. One moment. We'll have angered. I'll have angered OBS. One moment. Oh. That might have actually broken OBS. That's great. Just a second. I am having problems caused by me having to also restart the capture card in the process. I really don't want to have to restart OBS, but, you know. OBS is sometimes a bit stupid about these things. This is where I really wish I was running Esden's patches, because this wouldn't be a problem with those. Or at least it'd be less of a problem. Well, okay. Let's see if I can program the board now, though. That was the reason I did all of this, after all. Yes. Well, kind of. At least I can talk USB things again. That's nice. Where did I put that cable? I need to plug Glasgow in, or I need to take it out the chain completely. Actually, I'll take it out the chain completely for now. Why my keyboard no talkie to my adapter? I was able to do it yesterday. Oh, for the love of... Let me check on the other board, just see if it is this board or something else that's a bit weird here. So you can actually see what I'm doing. Let me put that there. This is dazzlingly bright. Okay. Like I said, dazzlingly bright. Oh, interesting. Alright, you can't see this because I forgot that. Yeah. Okay, that worked. Oh, I know what I've done wrong here. Okay. This JTAG adapter is crap in many ways. For some reason it was showing it as up and happy when it was not. Because I plugged in the board the wrong way around on it. I love Atmel hardware. It's so reliable. Hey, there we go. So in theory, I'm like, I could have sworn I didn't break this board. In theory, I should now be able to do Minicom, board rate, 2 megaboard on device dev TTY BMP Tog, I think it's called. I need to quickly plug my Blackmagic probe in. And attach the UART cable. Go in a hole. There we go. Yeah, okay. BMP Tog is a thing. That board rate. 8-bit mode with color on and attributes on. Okay. Let me turn the PS2 support off for now. I didn't add a new line in there. That's good. These all seem reasonable. Like if I type A, that's 4, B is 5, C 6. That is fair. Well, the important thing is we just got it doing scan code conversion. That's cool. Yeah, the old stuff doesn't really care about having a mux. In fact, you'll have a mux in there anyway to be able to do the turnaround. Because you got read and write all on the same pin, so... Okay. Let us, well, let us use this version of Git to, stage that, that, all of that can go in, as can that, and all of that. You physically can't, because the cable itself, the very end of the USB-C cable that goes straight into the keyboard has a pile of smarts on it that the keyboard can communicate with, and it's the only port on the exterior of the keyboard in Eston's project. It's very well thought out, yeah. You physically cannot plug more than one of these cables in at the same time. Physically impossible, which is good, because they're made of cursed. And I'm sorry I made that happen, because I might have made the suggestion that kick that off. I'm so sorry. Yeah, the USB-C to yes cable. I like that way of putting it. It is incredibly cursed, and that makes it almost better, I guess. So... oh, nice. Not that one. That one. So we've got to continue doing this now. I've now got to figure out this usage min-max thing, which is going to be interesting. Oh my. Oh, jeez. Kato 9 charger. Oh my. That's great. Oh, I love how at the very end it's like, Foon, did you do this? Like, we'll just pull Foon in now, just to make it extra cursed. Cool. This, circular cursedness is now complete. Ah. Good. This is, Aston, what have you done? Showing me this data sheet again. Hey. So application, collection. Let's find the collections part of this. This is input output feature items. Collection, end collection items. So there's an end collection item, which is a thing. So usage switch. Oh no, application. A group of main items might be familiar to them. Well, of course it is. It connects anything to anything else. Clearly. Okay, so everything that's inside a collection is a main item type. These are local. Adding physical descriptors. So I've gone past the main item type. Global. Okay, so we just define another main item. Oh, okay. So usage is 0. I think this is actually going to be something like main item team. It replaces you. You need to set a successor. Well, so you can only have one channel founder. That's the rule. There's only one channel founder. However, you can name a successor, and then once you've named a successor, you can then really? Okay, let me quickly have a look. Because I have the chance of help open. Hope set no founder, no command founder. What was the... Are you sure it's a set command? Because it's not appearing in the set output. You can set email, entry message, guard, keep topic, mlock, no sync private property, hub-ackle, restricted secure, topic lock, URL, and verbose. Now, mlock has the ability to set additional flags like someone is a founder. No worries. That was flags. Okay, plus F for full founder access. You actually want to do a oops. I edit my own messages. Twitch doesn't allow me to edit my own messages. That's really annoying. Anyway, it's that you want to do. I managed to miss my closing backtick, but whatever, you get the idea. That's the one you want. You don't want to use set, you want to use slash, you want to say flags, channel, nickname you want, plus F, and that will grant them founder. Do be careful with it. Founder has a very particular meaning, by the way. Including the fact that they can take over and kick you out at a no moment's notice. But, you know, if you're trusting the other person, that's fine. So usage minimum is an input. Usage... Oh no, that... Is that input? No, that would be 0001. Blazing heck. Oh, yeah. Yeah, in that case you give them founder when... And then you can defounder yourself, I think, or something like that, and that will transfer control. If you want to defounder yourself, of course. There are other ways to move control anyway, so... But... I am baffled by this. So, I know how this usage page bit... Oh, that's fair. I know how the usage page bit works, because this generates me hex 5, which is correct. But I'm trying to work out how on earth usage minimum is being encoded. We've got tag, which will be 0 for main. No. Oh yeah, that's all love and fair and fine. It's a learning curve, that's for sure. I think this must mean that this is a usage page thing of some sort. I'm not sure what that high bit is doing, which is in the tag area. It's very odd. The 9, however, which is 1001, size will be 1, and type is local. I wonder, is this descriptor T usage? Descriptor size 1. What does that encode to? Encodes to too many items in your damned array. 1U. No, that's not what I wanted to encode. So is this tag part is the high part. I'm guessing that's where the minimum maximum part comes from. Local will make that 9. Yeah. So yeah, this is the min-max part. Local items. Ah, there we go. Usage minimum, usage maximum. Interesting. I guess in many respects that is kind of what we're doing here, because you're building up a descriptor and... I don't know. That should be... Oh, 2.5. Why is that? Local... Oh, right, because this is giving it to me as a straight number, so 25 decimal in hexadecimal. One 9, and 2 9. That perfectly matches. Now E0 and 7. That's the next bit we've got. Oh, this is saying that the first byte can only be in that E0 to E7 range, right? That's totally what that is. If I find the... the keyboard keypad page. Yeah, it's saying it can be left control through right meta. That's what that's saying. How to do this? I put the key codes in the key matrix header, but really those key codes are actually a function of the HID spec. So really I should have actually put these in here. I guess that actually makes a lot of sense. So if I do this, so I got HID scan code T, and then in here I can then do, using scan code T equals and that means I now need to include the descriptors header, which is in here. I think that's right. USB descriptors. Oh, okay. One level of colon missing. Yeah. Right meta. And this is now 12 bytes long, so this is defining and this is defined as E0, E7, okay, so there's the scan code, so I'm allowed to put in that byte. Then there's logical minimum, logical maximum. So I need to add another 2, 3, 4, 8 bytes to the thing. So this is... I hit the scripter for logical minimum. The descriptor type needs to become 5, so it's global, I think. That makes that global. Yeah, these are global items. Logical minimum, logical maximum, 1 and 2. Makes sense. That probably means I actually need to pull these out into... a namespace for these things, which we then have struct global t enum struct, sorry, uint t usage is a global one. This is then usage page actually. And we have that one. Then another enum type in here will be enum struct local t. This is where usage minimum and maximum go, along with usage page again. This time it's a different usage page. I think. Oh, no, local items, it's just called usage at that point. So it's usage generic desktop usage page keyboard. Get the nomenclature right helps. And that actually allows us to get rid of this because it's already encoded by the namespace, and we can then do some funky stuff with type matching on operator OR to make this work. Collection is in main. So in that case, this is matching items global T and a uint8t size. Main. I love C++. Sometimes it makes things so nice because I can just get rid of that, that. This is a usage. Was that usage page or usage? Oh no, I see. This should be matching global T and uint8t. Oh, this has to be in that namespace, that's right. Easily fixed. And then I can move these down below the script type, where it then makes sense. This is now defined in time. Nice. So this one was a local T, I think. Yes, that was a local T. That's a local T. That's a global T. And that's way more descriptive. 5196 157. Yeah, this has worked perfectly. So we can then say report size. That's another global. It's 7. Oh, is that global? Oh, I'm looking at the locals. That's why. Yes, it is a global. Let's just transpose all of these into code. So we've got 3U, 4U, unit exponent 5, unit, which is 6. Report size is 7. Report ID is 8. Report count is 9, not A. Push is A0 and pop is B0. I think. Yeah, 9, A, B, and then unused. We'll come back to those ones because I haven't got a need for those quite yet. The report size 1. And there's that 8. Data variable absolute modifier byte. Ah. Yeah, 8.1 is an input. Okay. So the bits are, bit 0 is 0, so it's data. which is encoded as what's that obliterate? Input T data id input T variable id input T absolute. Oh, yeah, sorry. I can skip it. So that's that one. Then have a input item that's constant. Hi dear. Yeah. Oh, good to know. I'm so close to having a descriptor written. I really want to get this working so I can then actually have the keyboard try and do something. Oh, Kate's doing the key. No wonder why she's been so out of it for a bit. Bang Bang Con is a conference that is, how do I describe it? Yeah, the link's good enough. The link's a good way of describing it. It's good. This is what we're talking about. This is pronounced Bang Bang because, of course, it is. And, gosh, there's just so many cool people here. I believe it's streamed onto YouTube. Yeah, there you go. I'll actually have that ready for me to go. I guess. I'll try and keep that in mind as something to work to. So I have to make input T happen now. So we've got input T is a enum struct. Yes, you have, and made me have some what moments. Yeah, well. Bang bang Lulu bang. Bang. Mm-hmm. Yes, I do remember you mentioning about this, and having a hell of a lot of fun, more than you probably should have with it. It's good, though. So this is Const Expert inline Unit 8T operator pipe. No accept? Yeah, no accept. Yeah. If I then also make this so that there's a version that takes Unit 8T. No, sorry. Unit 8T on this side because of how I want it to stack. That should make all of this code valid. If I do that... Yeah, okay, that works. Nice. Where are we at? We have now got reserved byte. So we then have a report count 5. Hang on, report size 1, count 8. Then we get count once. Ah, okay. I had these the wrong way up. And we then have our report count 5. And size 1. This is for reporting the LED statuses. So this puts us at 32. The next one will put us at 34, because we now need to define the usage page. Which is page 8 apparently. Yes, I want you to do that too. I want to make this happen. And I'm not kidding, I really actually want that to happen. I think that's so cool that you want to do that. at least, trying to think what some of the back orders are currently at the moment. I think I have a processor running spare. I can get the LED drivers in soon-ish. I have the LEDs. What keys would you want? That's the next question. I have the USB-C connectors. I have the debug connectors. I should have added an extra PS2 port to my order of PS2 ports. Darn it. But I worry about it. Yeah. Okay, MX screens. That's fine. I need to just find a source for clear MX screens then. I thought they did. Okay. Make a stem transplant. Yeah, that's actually not a bad idea. Anyway, so we've got page for LEDs, usage minimum, usage maximum. This is to say that we want these first few LEDs only. I'm actually going to restrict it to 1 through 3. So we've got the usage minimum maximum stuff kicking back in again. I've gone over the boundaries again, so this needs adjusting back up. Makes that valid. Then I have to go and define LEDT. That will take just a moment. So under scan code T is enum struct LEDT. Tenkylus, I think. 60% if you exclude the navigation columns too. So 80 and 65% are the two sizes that you're thinking of. Tenkylus and also minus the arrow keys and that lot. LEDT needs undefined 0, num lock is 1, caps lock is 2, scroll lock is 3, compose 4, corner 5, power 6, shift 7, etc. I like my full size, but I am tempted to try Tenkylus if I have a numpad that I can slot on or have parked next door. Yeah, that's understandable. The boards get expensive for full size. Oh, and I know. I know, Eston. I know, Eston, why this does a turnaround. It's not doing a turnaround. The first part of the report are the current modifiers. The other part of the report, so you've got a part of the report that's modifiers, a part of the report that's for the LEDs, and a part of the report that's for keys. I think. No, that actually doesn't make sense. Never mind. That doesn't make sense. Wow, yeah, this is weird. Why does it suddenly switch from input to output and then back to input? Hmm. Hmm. You know, that's fair. Is it? Oh no, it's input T. I keep saying input. Wow. Data variable. Absolute. We are up to 40 bytes of descriptor. Just love how long this thing is. That's fair. So... get to remove that. Let's do some quick version control here. That. Yeah, so the feet on the Ergo docks are actually the feet I want to put on MX keyboard. That's how good I think those feet are, and how well designed I think the case on that thing is. Hmm. Seems reasonable. Jade does have good configs. I want all of that. And all of that. Move the scan code, USB scan code definitions into the USB descriptors header. Okay. So we then get a I'm gonna change this to 3 and 5, not 5 and 3. Apparently you have to have padding following this report. Which is fun. And then after that, we then have output constant. Input T needs renaming. I've just done the input thing again. So these are actually, oh, these are main T. Because they're also used for feature. Let's move that up. Next door to the collection types. Here will do nicely. And this is therefore main T. Another main T, I know, but you know. That just changed everything I needed to have changed. I love my IDE. That added another 6 bytes. I think. Alright, constant needs 0U on the front. Have auto conversion happen. We then have the scan codes, which is a report count of 6. Apparently this report size is supposed to be 3. I do not understand what's happening in that LED report. It's weird. What's happened with DHL? Oh. Yeah, okay. So, logical minimum 0. That's reasonable. Logical maximum of 101. That's 6.5. That's weird. That would be this. Oh, I see. Is anything not in the boot spec is above that, everything below. Okay, I understand why that's there. Yep. Yep. So this is scan codes. I'll define that it's scan codes before I define what the scan code usages are. And this was 6.5? Yeah, 6.5. And there's also a logical minimum maximum assigned with this. This is input data. Just grab that, that'll be easy to then customize data array. And then we have the end collection byte. Which is a global, I think. No, it was local? Oh, it is a main T. Okay. And that should... Well, we've added 2, 4, 6, 8, 10, 12, 14, 16, 17 bytes. That's 63. That actually matches the descriptor size that Eston had. That's nice. End collection is 192, so we should just see end of this be 192, and we do. Perfect. There we go. So this is read using get descriptor, I think. You're fine. It's okay. So we've got class-specific descriptors, hid, report, physical. So this was a report descriptor that we've just built. I know those feels. Okay, so yeah, I've done this. That's how... keyboard descriptor... Oh, hang on. So we've got config descriptor, interface descriptor, hid descriptor. I've then put the report descriptor in, but it is quite specifically telling me do not do that. So that's wrong. What was the top of the, or rather the bottom of the hid descriptor? This is really madly defined, I remember that. Hid descriptor is... hid descriptor, report descriptor T, hid, and then num descriptors. And then we okay, no, that is correct. We're sending that there is a report descriptor and how long it is. That's what this is describing. And then we have the endpoint descriptor following that. Yep, okay. That makes sense. So, additionally, I now need to handle hid, report, physical, and reserved. Well, no, I don't need to handle reserved, but I need to handle these three. So... in here, we have case USB descriptor T is hid, and case USB descriptor T is report. I don't implement physical for now because I haven't got a physical description. We can then ask if descriptor index is more than or equal to config. No, not config. Hid descriptor count? So this is the HID interface number. I'm gonna guess that that's if it's greater than 1, then we don't want to handle it, or if we are not configured into this mode, because we have multiple modes that the firmware supports already, which is... Oh, does the I think the keyboard might not yet handle being told to go into a specific mode. My kernel does not see me plugging and unplugging the keyboard. Oh no. I think I know which port decided to have a really bad day. Why? I don't know, but apparently it was the one MX keyboard is plugged into. If I do this with the front, yeah, can't set config 1. Error -32. So this firmware does not yet do set config. That explains a few things. I'm like, why is the code here missing for handling configs? That'd be why. I'm gonna call that USB HID descriptor, and we're gonna do the honors with that in just a moment. Because this is gonna be a multi-part. So I think that's correct for defining the multi-part table, which then means we then need to define static const. Oops, I forgot to make the other thing static const. Std array of USB multi-part descriptors. There'll be 2 of them. And we want the HID descriptor and report parts, because that is what that descriptor is, weirdly. So we need to do a multi-part transfer. Set part number to 0. Okay, so what I've just done there is I've told it to read back the descriptor, because we have to do this shenanigan to be able to get it out of Flash. Say that we're multi-part, set up the part numbering, and the first part of the descriptor, or rather, sorry, where the parts of the descriptor are, the multi-part table, and then return back that we want it to transfer the multi-part back. So this will do the honors, sending back the HID descriptor. I've just got to deal with that now. For a report, if the descriptor index is greater than or equal to the count of the number of HID reports, that will be this one, then it's bad. And again, we've got that OR condition to deal with, or we're not in the right mode. Otherwise, we need to do a similar thing where we pull back the multi-part table. Which I'll probably make an array. Well, not even probably. I will make it an array, because that makes sense in this instance. Yep. That even. So this is a multi-part table. That many descriptors in this table. Strings. I've not been terribly consistent in my pluralization, have I? Oops. Oh no, I have. I'm an Humpty Dumpty. So this is probably just USB reports. And there's exactly one, so we then need to initialize this with USB boot report sections begin, USB boot report sections end. Nice. And then in here, this is where we can finally define the descriptor to send back. Now, I'm guessing that it's not given here, but I'm guessing that I send back this, followed immediately by noted this. Yeah, that would make sense if that's gonna work how I think it does. And yes, that was my neck. Return response T data. Indicate that it's multi-part. Report descriptor total length from Flash. There we go. That should be everything. That should now get us HID reports, but of course I need to pull in the code for doing config, which I'll pull from SPI Flash Programmer. I think that's all for this week. I would like to watch this keynote, which sounds like it's going to be interesting and promising. I also need to deal with my system being a bit screwy today. But I think we've got a good deal of progress made here. For example, we've got, it does do scan code translation, something it did not do, God, not very long ago. Ooh. Thank you, Aston. And yeah, we've made some reasonable progress. We actually saw it do scan code translation, as we saw earlier, using the UART. So, with that, next week I plan on continuing this, I think, because I want to get the keyboard, at least configuring correctly, and hopefully sending the scan codes we've got translating, which should be an interesting stream as well. By then I hope I have got a certain parcel that I was really hoping to get to open and show on stream today, but such is life. With that, thank you all for watching, and have a good rest of your day. See you next week. Ciao for now.